going to a relative's place and you have lost your way. You show the address to someone passing by. What will you ask the person? Will you ask the distance to the place or will you ask the direction to the place? Obviously, the direction, right? Only knowing the distance will not help you reach there. So, in order to describe a location, direction also plays an important role. Some quantities can be described by just mentioning its magnitude. For example, mass of an object, length, which can be described by a number. Similarly, speed, distance, temperature are quantities which can be completely described just by a numerical value. Such quantities are called scalar quantities. But sometimes, to describe a quantity, we need to mention its direction too, along with the magnitude. If you need to throw a ball, you not only need to decide how hard to throw, but also should decide in which direction you have to throw it. So here, the force applied is the magnitude together with direction. Another example is the wind. To trace the wind at a place, we need to specify its speed and the direction in which it is flowing. Speed together with the direction is the velocity. Such quantities which can be described by its magnitude as well as direction is called vector quantity. In mathematics and physics, you will come across many vector quantities like this. Some other examples of vector quantities are displacement, acceleration, momentum, and so on. In this video, we are going to learn what vector quantities are. So first, let us define a vector. As we said earlier, it's a quantity that has magnitude as well as direction is called a vector. Given a line segment, it is a vector and it is denoted as vector AB or simply vector A with small letter a. Now, let's see the terminologies used in the vector. The point from where the vector AB starts is called the initial point. And the point B from where the vector ends is called the terminal point. And the distance between initial and the terminal points of a vector is called the magnitude or length of that vector. And the magnitude of vector AB is represented as modulus of vector AB. Next, we will see about position vector. Do you know what a position vector is? In simple terms, we can say it is a vector that describes the location of a point. Location in the sense, the distance and the direction. Usually, we represent it as R, vector R. So here, look at this figure. Point P is in a three-dimensional coordinate system having coordinates x, y and z with respect to the origin 0, 0, 0. Then the vector OP or vector R is called the position vector and the magnitude of OP is given by modulus of OP is equal to root of x square plus y square plus z square. And this equation for magnitude is using the distance formula which we have studied in earlier classes. Now, let's discuss about direction cosines. The position vector OP makes angle alpha with x-axis, angle beta with y-axis and angle gamma with z-axis. And these angles are called direction angles. Also, we can define direction angles as the angles made by a straight line with the three axes of a rectangular coordinate system. Here, alpha, beta, gamma are the angles and these are called as the direction angles. Now, the direction cosines of the vector R are the cosine values of these angles. So, they are represented by L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma. Now look at this figure. One thing we can cite from the figure is that the triangle OAP. It's a right angle triangle. So here we get cos alpha is equal to L is equal to x by r. From that we get x is equal to L into r, where r is a magnitude of the vector r. Similarly, from the other two right angles, we have cos beta is equal to m is equal to y by r, and from there we get y is equal to m into r, and similarly cos gamma is equal to n is equal to z by r. From there we get z is equal to n into r. Therefore, the coordinates of the point P can be represented as LR, MR and NR. Alright? And these numbers are proportional to the direction cosines of the vector R. And these are called the direction ratios of the vector R, and it is represented as A, B and C respectively. And one more thing we have to note here is that L square plus M square plus N square is equal to 1. Also, A square plus B square plus C square, that means the sum of the square of the direction ratios is not equal to 1 in general. Now, let's move on to the different types of vectors. Vectors are mainly classified into zero vector, unit vector, co-initial vector, collinear vector, equal vector and the last negative vector. Let's discuss one by one. First one, zero vector. From the name itself, we may identify that it is a vector having zero magnitude. To be more precise, it can be defined as a vector whose initial and the terminal points coincide with each other and is denoted by a zero, vector 0. And there is no specific direction assigned to this vector as the magnitude is 0. Here is a graphical representation and a dot is used to represent it and a 0 is written above. Alright. Next, we will discuss about unit vector. Mathematically, unity means one unit. So here, the vector having magnitude 1 is called a unit vector. The unit vector, which is in the direction of vector A, is denoted by A cap. You can see here. And this is a graphical representation. Direction is shown and with the magnitude 1. Alright. So the next one is co-initial vectors. What are co-initial vectors? These are two or more vectors having the same initial point. So you can see in this figure the vector A, B, C, D, E are all co-initial vectors because they have the same initial point O. Now let us see what are collinear vectors. We are familiar with the term collinear. What is that? If points are lying in the same straight line, they are collinear. So, what are collinear vectors? Two or more vectors are said to be collinear if they are parallel to the same line irrespective of their magnitudes and directions. Here are some examples. This is one example and this is also a collinear vector. Now, what are equal vectors? Two vectors, let's say vector A and vector B, are said to be equal if they have the same magnitude and direction without considering the position of their initial point. And these vectors can be written as vector A equal to vector B. Now, see vector A and vector B. These are equal vectors. So, A equal to B. Next, we can see what is a negative vector. We have discussed, and this is the last one. A vector whose magnitude is same as the given vector, but the direction opposite to that vector is called negative of the given vector. For example, consider a vector AB. Now, what will be its negative vector? It will be BA with the direction opposite to AB. Alright? And it is written as BA is equal to minus of vector AB. Now it's time for a sport quiz. Classify the following measures as scalar and vector quantities. Here I'll give you some list of quantities and you have to classify whether it is a scalar or a vector quantity. First one, 50 kg. Can you identify whether it is a scalar or vector quantity? We know 50 kg, it represents mass, and we know mass is a scalar quantity because it has only magnitude, there's no direction, right? So it is a scalar quantity. Second, 360 degree. What about 360 degree? Is there any direction? No. It is a scalar quantity again. Third one, 5 Newton. 5 Newton is actually represents a unit of force. So it is a force. So it is having direction as well as the magnitude. So it is a vector quantity. And what about 5 meters northeast? Is it only represents the distance? No. It's a represents a distance at a particular direction, northeast. So it is clear that it is a vector quantity. And the last one, 60 seconds. So here again, when we say about time, does it show any direction? No. So it is purely a scalar quantity. Hope you all understand what is a scalar and a vector quantity, right? Now, let's look at the figure and identify which vectors are collinear, equal, and co-initial. So first one, we'll discuss the collinear vectors. So can you identify from this figure? Here, if you look, vector A is parallel to vector C and also it is parallel to vector D. So A, C and D makes a one set of collinear vector. Similarly, what about this B and D? They are also collinear vectors, right? We have A, C, D, one set of collinear vector, and B and D, another set of collinear vector. Now, what about equal vectors? Here, you can see A and C are equal vectors, right? Because direction and the magnitude are same, right? But why not B and E are not equal vectors? There might be a question, right? They are not equal vectors because the direction is different. A is in this direction and B is in the opposite direction. So they are not equal vectors. Now what about co-initial vectors? Co-initial vectors means they should have the same initial point. So if you closely observe here, if you consider this is the same initial point, so vector B, vector C and vector D have the same initial point. So B, C, D are the co-initial vectors, right? So far we have discussed the various concepts based on vectors and come across various types of vectors. But what is the use of vectors if it is not used in mathematical operations? In the following video, let's delve deeper into the vector addition procedure. And here comes the summary of all the vector related ideas which we have discussed.
Manorama Horizon. Learning made simple.